Assalamualaikum and hi students. We will continue our tutorial with the last hour materials for chapter 2, face-to-face question 6 hour. Alright, the question is use the data below to construct a Born-Haber cycle for copper to oxide and determine its lattice energy. Alright, so like previous question, okay, non-face-to-face question, here you still have to construct a Born-Haber cycle for copper to oxide, where the chemical formula for copper to oxide is CuO, right? And after that, you have to determine or calculate the lattice energy. Alright, if you refer to the question gives you the name of the enthalpies and the values, right? But the question did not provide, right, the thermochemical equation. So what you have to do is you have to convert all these uh, enthalpies uh, into their thermochemical equations respectively. Alright, so let's start with the first enthalpy of atomization of copper. So this is the thermochemical equation that represents the enthalpy of atomization of copper. So we have copper solid atomize and form 1 mole of copper gaseous atom. So the enthalpy change here is enthalpy of atomization of copper, which is positive 339 kilojoule per mole. Right. So next we have first ionization energy of copper. Alright, so now transfer it into its thermochemical equation. First ionization energy of copper. So we start with copper gaseous atom. Alright. Okay, it remove 1 mole of electrons and form 1 mole of copper ion in gaseous state. So copper plus, because the copper gaseous atom undergoes first ionization. So this is the first ionization energy of copper, which is positive 745 kilojoule per mole. Alright. Next, we have second ionization energy of copper. So continue from copper plus gas. Okay, the copper plus gaseous ion removes another 1 mole of electrons and forms copper 2 plus gas. So this is the second ionization energy of copper, which is positive 1960 kilojoule per mole. Alright. Okay. Next, we have enthalpy of atomization of oxygen. Okay, so this is the thermochemical equation. So we have oxygen molecule gas undergoes atomization and form oxygen gaseous atom. Since the oxygen gaseous atom must be 1 mole, so we have to put half here. Alright, so this is enthalpy of atomization, okay, of oxygen, which is positive 248 kilojoule per mole. Okay, now we have first electron affinity of oxygen. Okay, so starting with oxygen gaseous atom, it gains 1 mole of electron and forms oxygen or O minus, O minus gaseous ion. Okay, so the enthalpy change is called first electron affinity of oxygen, which is negative 141 kilojoule per mole. Okay, right now continue. Alright, continue with the second electron affinity of oxygen. So we have 1, 2, 3, 4, 5, 6. This thermochemical equation number 6. Okay, that represent second electron affinity of oxygen. So starting with O minus gas, okay, gains 1 mole of electrons and forms oxide gaseous ion. Okay, so the value, the enthalpy change is called the second electron affinity, which is positive 791 kilojoule per mole. Okay, and the last thermochemical equation that shows the enthalpy of formation of copper to oxide. So copper to oxide is formed from its element, okay, copper solid, right, plus oxygen molecule gas, okay, forms 1 mole of copper oxide, CuO solid. So since copper oxide solid must be 1 mole, okay, so we have to balance the equation. So here is half mole. Stoichiometrical coefficient is half. Okay, and this is the enthalpy of formation of copper to oxide, which is negative 155 kilojoule per mole. Okay, so now you need these thermochemical equations to construct the Born-Haber cycle. Alright. Okay, so in this slide, in this video, I will show you the simple Born-Haber cycle. Okay, Born-Haber cycle dalam bentuk simple energy cycle. Alright. Okay. So now let's continue. Alright, you have to refer to the thermochemical equations yang kita keluarkan tadi. Okay. To construct the simple Born-Haber cycle. Alright. So firstly, we start with enthalpy of formation of copper to oxide. So we have copper solid reacts with half mole of oxygen gas. Okay, the reaction produce copper to oxide, CuO solid. Okay, so this is the enthalpy of formation, which is negative 155 kilojoule. Alright, and now each element must undergo atomization. So we start with copper solid. So copper solid undergoes atomization and form 1 mole of copper gaseous atom. So thermochemical equation yang mana terlibat? Thermochemical equation that represent the first value of enthalpy tadi. Enthalpy of atomization. So tengok tadi equation yang tadi. Jadi yang ini saya dah buatkan dia punya conversion. Right, so this one is enthalpy delta H1 or enthalpy of atomization pun boleh juga. So kalau kita nak label enthalpy of atomization, boleh jugalah. So let's say saya letak kat sini enthalpy of atomization. Okay, tak muat. Saya letak kat sini delta H1. Okay, which is equals to positive 339 kilojoule. Okay, insist unit mesti ada. And now oxygen undergoes atomization where it will form 1 mole of oxygen gaseous atom. So this is also enthalpy of atomization of oxygen, numbered as delta H2. Okay, so the value is this one for enthalpy of atomization of oxygen is positive 248 kilojoule. Alright, so both elements are settled with atomization. And now copper gaseous atom undergoes first ionization energy. So 1 mole of copper gaseous atom remove 1 mole of electron and form 1 mole of copper gaseous ion, copper plus gaseous ion. So this energy changes is called first ionization energy. Okay, numbered as let's say here delta H3. Okay, the value is positive. Okay, the second enthalpy positive 745 kilojoule. And now oxygen gaseous atom undergoes electron affinity and form O minus gas. Alright, so this is first electron affinity of oxygen. Okay, numbered as delta H4. Okay, sambung saja. So the value is negative 141 kilojoule. Okay, sebagai peringatannya, di sini biasanya berlaku kekeliruan. Ada pelajar kata, cikgu, kenapa delta H untuk especially yang melibatkan non-metal, oksigen, klorin, dia kata tak bagi 2 kat sini. Sebab kat sini dia kata ada setengah. Okay, tapi kenapa delta H ni kita guna je daripada soalan? Sebab sekarang kita bercakap pasal apa ni? Proses ini adalah atomization of oxygen. So, lihat balik definition enthalpy of atomization. Heat absorbed when 1 mole of gaseous atom is formed. So, yang kena 1 mole adalah kat sini. Jadi sekarang kalau kita tengok, kita mesti balance equation ni, kita mesti balance. Oksigen mesti semua sekali dalam cycle ni mesti 1 mol. Jadi kalau you tengok pada data, unit dia per mol, per mol, per mol. Semua represent oksigen itu mesti 1 mol. Oxide, O minus gas mesti 1 mol. Oxide pun nanti O2 minus mesti 1 mol. Jadi sekarang 1/2 daripada 2 ke 1. Ini pun 1. So semua dah balance. 1, 1, 1. Nanti kalau kita sambung 1 juga. Jadi oleh kerana dalam equation ini oksigen tu adalah 1 mole secara stoichiometrically ya. Okay. Jadi kita tak perlu bahagi 2 nilai delta H tu. Okay. Alright. So saya delete dulu bulatan ini. Okay. So kalau masih tak jelas kita tengok seterusnya. Okay. Copper undergoes the second ionization where copper plus gaseous ion remove 1 mole of electrons and form copper 2 plus gas. Right, so this is called second ionization energy of copper, numbered as delta H5 here. Okay, the value is positive 1960 kilojoule. And O minus oxygen atom undergo second electron affinity. Jadi O minus gas dia akan gain 1 mol elektron lagi and form O2 minus gas. Okey, ini yang saya sebut tadi. Kalau you tengok kat sini, oksigen semua dah balance. 1, 1, 1, 1. Nanti kat atas ni pun 1, nampak? Dekat CO pun ada 1 oksigen kan? So dia dah balance. Jadi per mol merujuk kepada 1 mol. 1 mol oksigen, 1 mol copper. Jadi nilai delta H untuk oksigen tak perlu bahagi 2. Sebab mentang-mentang kat sini ada 1/2, ada pelajar ingat delta H perlu bahagi 2 kat situ. Tidak. Dia tengok kes. Ada yang perlu darab 2. Ada yang tak perlu. Macam dalam kes ni tak perlu bahagi 2 lah. Okay, so that's why kena buat banyak soalan. Terutama soalan passes lah. Ataupun apa-apa soalan yang saya beri. Okay, so sama kat sini tadi. This one is second electron affinity of oxygen, numbered as delta H6. Alright, okay, and the value is positive, okay, 791 kilojoule. So when these ions, gaseous ion combines, copper 2 plus gas combines with O2 minus gas, dia akan form apa? So dia akan form, saya ingat pula. Dia akan forms copper oxide solid. Okey, jadi untuk memudahkan kerja saya guna ruler lah kat sini. Okay, so when this gaseous ion combines, it form 1 mole of solid copper to oxide. So the enthalpy change is called lattice energy. Okay, so in this case, it is numbered as delta H7, which is unknown. Alright, okay, so to solve the problems, you will use Hess's law. By applying the Hess's law, alright, so write down the formula, show the substitution. So finally, the answer should be negative 4097 kilojoule per mole. Alright, so this is the way how we construct the Born-Haber cycle for copper to oxide by using simple energy cycle bagi Born-Haber tersebut. Okay, so untuk yang energy level diagram, I'll show you yang dah siap buat lah. Jadi you boleh tengok contoh sebelum ni, dalam video sebelum ni, and try to construct Born-Haber cycle dalam bentuk energy level diagram. Okay, so this one adalah Born-Haber cycle in a form of energy level diagram yang telah siap dibina. Jadi caranya untuk bina yang ini saya dah tunjukkan dalam video sebelum ini, iaitu soalan non-face to face 6 hour. Alright, okay, saya harap semua pelajar go through lah benda ni. Okay, so continue with the next question. The last question for chapter 2. Okay, arrange the following substances in ascending order of lattice energy and you have to explain your answer. Alright, jadi kita kena susun ketiga-tiga ionic compounds ini dalam turutan ascending order. Ascending order maksudnya increasing order of lattice energy. Okay, daripada yang less exothermic ataupun less negatif kepada yang more exothermic or more negatif. Okay, tapi sebelum kita susun tu, kita kena identify dulu what factors that affect the trends. Okay, faktor apa yang mempengaruhi? Adakah faktor ionic size ataupun ionic charges ataupun mungkin kedua-duanya. Boleh jadi juga kedua-duanya. Okay, untuk itu kita buat sedikit analisis. We have to analyze. Okay, we have aluminium trichloride. So dalam aluminium trichloride kita ada apa? Aluminium ion Al3+ and chloride ion. Ada 3 chloride ion lah. Saya tulis satu saja. Okay, and then we have magnesium chloride MgCl2. So we have magnesium ion Mg2+ and Cl-. Ada 2 Cl- actually. Okay, and we have sodium chloride. We have sodium ion and chloride ion. Okey, jadinya sekarang kalau kita tengok dari segi cations, dari segi anion. Anion dia semuanya adalah Cl-, Cl-, Cl-. Okey, jadi sekarang ni maksudnya Cl- tu seolah-olahnya tidak memberi kesan ataupun mempengaruhi trend lattice energy ni. Jadi kita kena tengok kepada cation tu pula. Cation kita berbeza. Berbeza dari segi apa? In terms of charge, you nampak aluminium 3 positif, magnesium 2 positive and sodium ion is 1 positive. So the larger the charges, the charge of the cations, the stronger the electrostatic attraction between the cations and anions. Jadi kalau you nampak kat sini, kita boleh guna juga faktor the ionic charges. Okay, ionic charge. Kita boleh guna juga. Tapi kalau kita selidik satu lagi, kita boleh nampak di sini. Okay, kita boleh nampak di sini sodium ion, magnesium ion, aluminium ion ni, they are ions which is come from period 3. Ini pelajaran semester lepas, periodic table. Okay, we have sodium ion, ions from group 1, and then we have magnesium ion, ion which is come from group 2, and we have aluminium ion which is the cations from group 13. Okay, jadi kalau kita ingat balik across a period, okay, untuk cations, okay, what happened? The size of cations become smaller, makin kecil. Jadi makin kecil, bila makin kecil, maksudnya sekarang ni saiz aluminium ion tu lagi kecil berbanding magnesium ion and sodium ion. So electrostatic attraction antara aluminium ion and chloride ion tu lagi kuat berbanding electrostatic attraction between magnesium ion and chloride ion, and also sodium ion and chloride ion. Jadi kalau kita tengok dalam soalan ini, actually kita boleh guna pakai kedua-dua faktor. Okay, you nak guna faktor apa? You nak guna faktor ionic charges tadi pun boleh. Okay. Ataupun you nak guna faktor ionic size pun boleh untuk soalan ini. Kadang-kadang soalan dia bagi satu faktor saja yang mempengaruhi. Kebetulan soalan ini dia bagi kedua-dua faktor. Jadi kita boleh guna salah satu faktor lah. So kalau you nak pilih faktor yang pertama, gunakan faktor yang pertama tu untuk kita explain. So kalau kita nak guna faktor yang kedua, kita boleh guna faktor yang kedua ni untuk explain. Jadi saya tunjukkan suggested answer. You boleh review satu persatu lah. So pilih mana yang you nak guna. Alright? Okay. Okay. So first of all, you have to arrange. You kena susun dulu dalam turutan ascending order. Wajib susun sebab soalan dah tanya. Jadi, tapi sebelum susun, saya kata kita tengok apakah faktor yang kita nak pilih. So, kalau you tengok, abaikan dulu susunan. Okay, you tengok kat sini. Katakanlah, you nak guna faktor, you dah kenal pasti tadi, you nak guna faktor ionic charges. So, you kena susun, maksudnya lagi greater, the bigger or the larger the charges, alright. ataupun bila dia punya charge increases, the electrostatic attraction juga akan become stronger. Jadi you tengok kat sini kalau kita guna ionic charges, the ionic charges of cations increase from sodium ion to magnesium ion or to aluminium ion. Okay. Okay. Jadinya sekarang, so what kalau ionic charges of cation increase daripada sodium ion to aluminium ion? Okay, the higher the charges of the cations, the stronger the electrostatic force of attractions toward the chloride ion. Okay, ini saya sedang bincangkan faktor yang pertama. Okay, right? Jadi maksudnya sebab itulah susunannya adalah seperti ini. So, kita kena susun, kita kena explain. Kalau you gunakan faktor yang kedua, if you use the second factor, ionic size, okay, yang warna hijau, the ionic size of cation decreases from sodium ion to aluminium ion. Macam biasalah, so what kalau ionic size tu makin berkurang, makin kecil from sodium ion to aluminium ion? The smaller the ionic size of the cations, the stronger the electrostatic force of attractions towards chloride ion. Plus lattice energy increases. Jadi you pilih salah satu faktor yang mana you nak pilih untuk explain. Alright. So saya harap boleh buatlah ulang kaji, because untuk UPS 1 dia akan masuk from chapter 1 until chapter 3. So chapter 2 ni dah wajib untuk you buat revision. Okay class, that's all for the lesson. Thank you.